let's take a look at number 8, page 69 in 2.5. So we want to solve the equation 3x squared plus y dx plus x squared y minus x dy equal to 0. So first you check to see if it's linear or separable. And you can see by the coefficients that it's not linear. And if you try to separate variables, it's not going to happen. So so let's state that. So not linear, not separable. Okay, so the question is it exact? No, obviously it isn't going to be, but you still want to check it because, right, I want to show you how you kind of step through everything. So here's your m x y. Here's your n x y. So you check it. So let's do the partial m respect to y. So if you do that, you get 1. Is that equal to partial n with respect to x? If you do that calculation, you get 2x minus 1. So no, these are not equal. So let's state that. Therefore, not exact. So now let's do the calculation to see if we can get a function of one variable. So now we're going to calculate. We'll do the partial. So basically, you try either one of these. This is the one this one works. Let's just take a look. So partial m partial y minus partial n partial x all over n. So you do that calculate that, see what you get. I'm going to move this down here. So that's equal to do that calculation, partial my, well, that we did them above, right? So it's just 1 minus 2x minus 1 over x squared y minus x. And we want to simplify that. That's 2 minus 2x over x squared y minus x. Continue to simplify. We get 2 times 1 minus x over, so if you flip that, you factor out a negative x, you get 1 minus x. So this is negative 2x, provided x is not equal to 1. Okay, so we may need to deal with that later, but for now we're just going to calculate this. So is that a function of just x? And it is. So and f, and it, I'll just say and is only a function of x. So therefore, an integrating factor is mu of x. So you calculate mu of x, so it's e raised to the, all that we just did. So you don't have to redo it. So we can factor out, so it's all of this. That's the integrand when you do your calculation, and that's all of this. So you can factor out the negative 2, and it's the integral of 1 over x dx. And of course, that's just e to the negative 2 ln opposite value of x, which is e to the ln opposite value of raised to the negative 2. So you can drop the opposite values at that point. So it's e to the ln x to the negative 2, which is equal to x to the negative 2, or 1 over x squared. So that's our integrating factor. So now multiply on both sides of the given equation. Obviously, the right-hand side will just be 0, but that's what you do. Okay, so we get all of that. So it's 3x squared plus y. And then you have your x to the negative 2 dx plus x squared y minus x times x to the negative 2 dy equal to 0. So we know that's exact, but let's check it out. So let's simplify that a little bit. Go ahead and bring the x down, do a little simplification, and you end up getting 3 plus y over x squared dx plus y minus 1 over x dy equal to 0 is exact. Okay, it's exact, but this time we're gonna check it. Okay, so but let's check just to convince ourselves. Just to convince. Okay, so this is your mxy, this is your nxy. And so if you do your calculation, partial m respect to y, you can see that's 1 over x squared, which is equal to partial n over x. Do that calculation, which is 1 over x squared. Okay, so it works. Okay, so yay, it works. Okay, so yes, exact. Okay. I mean, it may not be as obvious. I mean, obviously, I worked it out, but you can just see when you do this guy here, you get this. Double check that if it wasn't clear. Okay, now, so if it's exact, we follow the procedures above in the previous section. So, therefore, there exists a function f such that, oops, I used a d, such that partial f respect to x is equal to 3 plus y over x squared, and partial f respect to y is equal to y minus 1 over x. And so now we integrate. And so we say f of xy is equal to the integral of partial f respect to x dx. And so we integrate that, you get partial f. Okay, so you get the integral. I was checking out my other stuff. I had messed something up. So it's 3 plus y over x squared dx. So you integrate that. Oops. Hold on, it's got to fix something real quick. All right. So that's equal to 3x minus y, x to the negative 1, and then you say plus an integrating constant, or just in terms of y. And then we also calculate, or we do this again, partial fx, or f of x, y is equal to the integral of partial f, partial y dy, which is equal to, and you don't have to, let's just take the integral. You don't have to write it all out. I mean, it's pretty much right there. So you're integrating that. And so you get 1/2 y squared minus y, x to the -1, plus h of x. So now, this is how, I don't think the book does it like this. This is how I'm showing you. I like to do it like this. You just compare them. It's not that tough to really just see what your g of y has to be or a g of x has to be, or if you just have, or it's just a constant. So we can see then that we have that g of y is the 1/2 y squared that ended up there. And the h of x would have to just be the 3x. And then you always put in a plus c. So hence f of xy is equal to 1/2 y squared minus y over x plus 3x. And an implicit solution is given by y squared over 2 minus y over x plus 3x, and then equal to a constant. Or you could say plus c equals 0. It doesn't matter. All right, so one thing we have to look at is, did we lose the solution? So let's see, how do I want to say this? All right, so mu of x is equal to 1 over x squared. So you want to check, did we lose a solution for x equal to 0? So in other words, the original function was defined before, where are we at back here? Okay, so this original one is defined at 0, so you want to check that, and then, but once you introduce the 1 over x, then it's not defined. So did we lose a solution is the question. All right, so all right, so check that. So is that a solution? And you'll see that it is. So in the original, if you say, so it is a solution. So basically that's 0. Who cares? But d, the derivative of that's just 0. That's both 0. So basically you get 0 equals 0. So 0 is a solution to that. So check that. Look at it more carefully. So the answer to that question is yes. X equals 0 is a solution to the original equation. So therefore, y squared over 2 minus y over x plus 3x equal to c, and x equals 0 is a general solution. So that might, that might come up here and there. Okay, let's try another one. Let's take a look at number 10. Number 10 is also on page 69. Solve. Oops. Made a circle. So solve 2y squared plus 2y plus 4x squared dx plus 2xy plus x dy equal to 0. So first, linear, no. Separable, no. So you check both of those. And then let's do our partials. Exact, partial m, and I was going to change up the colors here. So let's take a look at partial m respect to y. That's the partial of all that respect to y. So it's partial of 2y squared plus 2y plus 4x squared. That's equal to 4y plus 2. To calculate partial in respect to x. It's partial respect to x of all of that. So that's 2xy plus x, which is equal to 2y plus 1. Are they the same? No. Okay. So not exact. So partial m respect to y does not equal partial in respect to x. So therefore, the given function, or I say function, the given equation is not exact. So this guy is not exact. All right, so let's calculate then the integrating factors. Well, not the factor itself, but calculate partial m respect to y minus partial in respect to x all over n. So try that. This is probably where I'd have you work on all this together. Get that. You'll see that it's just a function of x, and then you calculate your integrating factors. So this is definitely one I'd have you try it on your own, because we just saw one all together. So let's work on it. We'll now work on it together. So 4y plus 2 minus 2y plus 1 over 2xy plus x. So it's 2y plus 1 over x times 2y plus 1 equals 1 over x. So that's only a function of x. And so now calculate your mu of x, just like above. Okay, so it's e raised to the integral of 1 over x dx. So that's just basically what that's going to be, e raised to the ln absolute value of x, which is just absolute value of x. All right, so what you have then is basically if x is positive, you get x. If x is negative, you get negative x. Now, if you multiply by negative x here, you could easily clear out that negative just by multiplying by negative 1. So it doesn't matter. There's no loss of generality by multiplying by x or negative x on both sides of the equation. Okay, so think about it. So it doesn't matter which one we use. So we're just going to use x. Okay, so just to kind of finish the statement here. All right, so that's what you get. Let's finish that again. So you get just x, that's how it's defined. So this is how it literally is defined. So it's just x if x is greater than or equal to 0, and then if it's negative x if x is less than 0. So, but there's no loss of generality whether you multiply an x on both sides or negative x on both sides. So either case works just fine. Okay, and I did write all that out in my notes. I'll probably post, but let's just keep rolling here. So multiply by x. On both sides. 0 on the right-hand side cancels it out, of course. And so you end up with 2, let's see, where is it? 2, there it is. 2y squared plus 2y plus 4x squared, and then we're going to multiply by x dx. And then plus 2xy plus x, and then times x dy equal to 0 times x, which is, of course, just 0. All right, so you'll distribute and simplify, and so this will be your partial f respect to x, and this will be your partial f respect to y. So we integrate just like we normally do. Now it is exact. You don't have to show that it's exact, right? You can just do it. So we're integrating this function 2xy squared plus 2xy plus 4x cubed dx, and you get x squared y squared plus x squared y plus x to the fourth plus some function of y. Let me do that again. Fxy, and you integrate your where'd it go? Oh, 2xy I messed up my work there. 2xy. Oh, okay, yeah. 2x squared y plus x squared dy. Okay, so that's what you're integrating. And you get your x squared y squared plus x squared y plus h of x. So if you compare this, you can see pretty straight up that your h of x, function of just x, would just be this one. And does that have the other one have a function of just y? Well, no, they're exactly the same. So these are all the same. So that doesn't, you don't touch that. So this g of y is just 0 or just a constant. So there's no function of just y. All right, so therefore, your f of xy is equal to x squared y squared plus x squared y plus x to the fourth. And our general function, x squared y squared, or equation I should say, sorry, keep saying function. General equation, x squared y squared plus x squared y plus x to the fourth equals c, is a general solution. Okay, so that's the technique. I didn't do one where you do the other partial to get a function of just y. You can try it, but frankly, you just do one or the other, and if it works, it works. So these will be a little more cookbook and solving the equations than frankly I'm used to, but that's how we will do them. So if I give you an example, you'll just try the different techniques. I might say use this technique because we're developing so many different ones in this case. All right, next we got a few different types of things to look at in 2.6, and then we'll be done with chapter 6.